Hello everyone, and welcome to Introduction to Matrices. This is part 1 about learning about matrices. Let's get started. We have some content today. We'll learn about basic vocabulary. We'll talk about how matrices are put together and set up. And finally, we'll talk about where they're used in real life, because it's always important to learn where the math is used in real life. But first, what is a matrix?
Do you want to know what it is? The matrix is everywhere. It is all around us. Even now, in this very room. You can see it when you look out your window or when you turn on your television. You can feel it when you go to work, when you go to church, when you pay your taxes.
Okay, thank you for that, Morpheus. Now, our vocabulary. Matrix is the singular, meaning 1. So here we have the matrix A, noted by the letter capital A. We use capital letters for the names of matrices. And it has 4 elements, A, B, C, and D. This is a 2 by 2 matrix. Matrices is the plural, so here we have 2 matrices, A and B. Notice that they have different configurations. The matrix A is 2 by 2, 2 rows and 2 columns. The matrix B is 2 by 3, 2 rows and 3 columns. All 3 of these matrices are 2-dimensional, or 2D. We can also have vectors. Vectors are a kind of matrix. Here we have a column vector going up and down, or we can have a row vector going left and right, but both of these are a kind of vector. These are 1-dimensional because they only go in one direction, either up-down or left-right. So how are they set up? So here's our example matrix B with the elements A, B, C, D, E, and F. So the first thing to note is that the matrix B has 2 rows. The first row, A, B, C, and the second row, D, E, F. Rows go left and right. The next thing is, this example has 3 columns. Columns go up and down. So we talk about the rows and columns as the order of the matrix. In this example, the order is 2 by 3. So we say 2 rows by 3 columns gives us the order 2 by 3. We say by for the X in the middle there. So this matrix is order 2 by 3. Always remember to speak of rows before columns. To help you remember, think of RC cola. Rows, columns, RC. We can talk about the elements, which are the members inside the matrix, using subscript notation. For example, this matrix has elements from B sub 1, 1, meaning the element at B row 1, column 1, through B sub 2, 3, meaning the element at row 2, column 3. Sub meaning under, like, well, submarine, which is something that goes under the water. You're already very familiar with tables holding data, such as this two-way table, having information about Cokes and root beers sold in 3 different sizes. But this information could be kept in, you guessed it, a matrix. So here we have our table put into the matrix D. Notice that in the matrix, we no longer have small, medium, and large for our column headings, and we no longer have Coke and root beer for our row headings. This information is just understood by the element's position within inside the matrix D. For example, we just have to remember or know that the value 2 in the lower right means number of large root beers sold. So let's look at this. Here our matrix D is the number of soft drinks sold in 1 hour at a store. So first we can ask a question like, how many medium Cokes were sold? Well, remembering the positions, this would mean that the answer is 12. 12 in row 1, column 2. Row 1 being Cokes and column 2 being medium. This goes to the element D sub 1, 2. What information is given by the element D sub 2, 1? Well, this would be row 2, column 1. So you should remember that this would go with the number of small root beers sold. Or 3. 3 small root beers. So here we have some sigma notation. What is the value of the sigma or sum as j goes from 1 to 3, d sub 1j? Well, this would be summing the 3 values across row 1. So it would be 9 plus 12 plus 11. So that would be 32. And the information of this is the total number of Cokes sold for all 3 sizes in that 1 hour. 32 Cokes. So here we have another sigma notation. Here we have I going from 1 to 2, D sub I 2. So this would be in the 2 rows, 1 and 2, but only in column 2. So this would be the number of medium drinks sold, both Coke and root beer, which would be 19. 19 medium drinks sold. And the last one, what is the value of this, and what information does it tell us? Well, here we have 2 sum or 2 sigma notations, with I going from 1 to 2, and j going from 1 to 3, and d sub ij. Well, if you study this for a moment, you'll see that this will cover all 6 elements of this matrix D, as j spins inside of I. And so this would give us the total drink sales for the store in that hour, which would be 44, from 9 plus 12 plus 11 plus 3 plus 7 plus 2. So the total drink sales for that hour at the store. Everything we learn has its purpose or application, and once we understand these applications, we understand the subject better. So what about matrices? Matrices are used in many places in real life, such as designing or analyzing computer circuits, recording or studying information about geology, such as earthquakes, in economics and business to talk about the trend or future of a business or the economy, in statistics about populations, in anime to control the objects in the anime on the screen to make them move more smoothly and crisply, in data encryption to encrypt your information between your computer or phone and, for example, the bank, in computer games to move and control the objects on the screen, in construction to modify or describe the construction of a building or to help with the preservation of a historical site, and in dance routines. Complicated dance routines can be represented by matrices in order to plan and modify those routines. So these are just some of the ways that matrices are used in real life. Okay, thank you for watching. That's all we have for today. Bye-bye.